So sometimes we're just given the graph of a function, and we need to find the domain and the range from it. So this is actually easier than working with a formula. And in fact, if we'd like to find the range from a formula, usually we have to think about the graph of the function. Usually, I would say, not always, but if the function is complicated, we're going to have to think about the graph. So here it's easier. We're given the graph. So for example, in figure 8, notice how the graph is drawn. So it starts with a full dot. This is telling us actually at -5 the function is defined. Okay, if there would be an empty dot here, the function would be undefined at -5 and then start being defined after above -5. And after that, you see this curve. There's an arrow there, so this is just to tell us it keeps going down and down and down. And there seems to be some sort of asymptote, like I don't know, it doesn't seem to go beyond 5. So this is what we can think. This is what I'd think if I see this graph here. Okay, so if we look at the domain, it's what you see in red here. This line that starts at -4 and then keeps on going. So I'm not sure what they wrote. I would have written the domain would be from -5 to 5 excluded, but it's debatable, right? Whether this is an asymptote or it's just that because it goes it's so steep that eventually it can reach any point in this region, but you'd have to wait a long time because it's really steep. So let's see what their answer is here. We can observe that the graph extends horizontally from -5 to the right without bound. Okay, so they assume that it doesn't stop. So once again, that's the thing with the graph, right? You cannot actually really tell 100% like what's going on with it, especially in these cases. Is this a graph that's just really steep but eventually it can reach? I mean, it could be defined for any value of x, or is there an asymptote? That would be debatable. So, but here they assume it's defined like for any x above -5. So this interval would be the domain. For the range, it's a bit more clear. So it starts at 5 included, right, because of a full dot, and then it goes all the way to -infinity. So from from 5 to -infinity, or preferably from -infinity to 5. This one's easier. Okay, so this one's pretty clear because it starts there, it ends there. We know exactly what we're dealing with. Okay, so there's no possibility of asymptotes or anything like that. But one feature that's interesting here is we've got this empty dot, which means that at -3 the function is undefined. There'd be a full dot if the function at -3 would be 0, but since there's an empty dot, f of -3 is undefined. But there are full so one thing that you want to think about when you see a curve like this, it's like a succession of full dots, okay, and it ends with an empty dot. So you've got full dots here, 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 here. So obviously the function is defined for all values above -3 until you get to 1, and it ends with a full dot. So f of 1 is -4, and it's defined at 1, okay, because of the full dot. So the range would be from -3 excluded to 1 included. And what's the range? The range is along the y-axis. We have values is 0 included, where, well, at -3, the y-coordinate is 0 for this empty dot, but the function is not defined at -3. So we have to look along the x-axis. Is there a full dot somewhere? And there's actually one here at the top of this curve here. Actually, there is a value where the y value is, there's a point where the value is 0. It's the point 0, 0. So 0 is actually part of our range. And we get all numbers all the way up to -4 included because of the full dot. So it's actually a close interval from -4 to 0 with the bounds included. So this is what you see here. So -3 to 1 is your domain, and -4 to 0 with both bounds included is your range. So look at these diagrams here for the domain and the range.